For most civilizations in the galaxy, space travel had long ago become flawless. Starships repaired themselves. Hull fractures sealed automatically. Engines diagnosed their own failures and corrected them before a pilot even noticed a warning light. Entire maintenance crews had been replaced by systems of artificial intelligence and microscopic repair drones that lived inside the walls of every vessel. Perfection had become normal. Ships left their home worlds, crossed light years of empty space, and returned without a single technician ever touching a tool. If a component failed, automated factories inside the ship fabricated a replacement. If a system malfunctioned, diagnostic algorithms identified the problem in milliseconds and solved it faster than any living engineer could react. Because of that, most alien civilizations eventually abandoned manual repair entirely. Mechanical work became something primitive species did during their early technological centuries. Once machines became intelligent enough to maintain themselves, the idea of a mechanic crawling through engine conduits with tools seemed almost absurd. By the time humanity entered the wider galactic community, the role of the repair technician had practically disappeared. Humans, however, never quite abandoned it. On the outer edges of busy trade routes, human orbital stations operated simple repair bays, large metal hangars filled with tool racks, diagnostic scanners, welding torches, spare components, and crews of mechanics who still believed that sometimes the best solution involved opening a panel and seeing the problem with your own eyes. Most alien captains initially avoided these places. Compared to the sleek automated maintenance docks used by older civilizations, human repair stations looked chaotic. Equipment hung from the walls. Crates of spare parts stacked in corners. Engineers moved through narrow corridors carrying tools instead of controlling swarms of repair drones. To many alien observers, it looked less like advanced engineering and more like controlled disorder. Yet slowly, something strange began to happen along the trade lanes. A merchant vessel suffered a catastrophic engine shutdown far from its home system. Automated repair programs failed to identify the cause. The captain diverted toward the nearest inhabited station, which happened to be human. Several hours after docking, the ship departed fully operational. Then an exploration vessel arrived with navigation systems that refused to synchronize with its own star maps. Automated diagnostics insisted nothing was wrong, yet the ship remained unable to jump to faster-than-light travel. Human mechanics spent an afternoon examining the navigation core. By the end of the day, the vessel jumped away without issue. At first, these incidents were dismissed as coincidences. But the stories continued. Cargo carriers arrived drifting and powerless. Patrol ships arrived with life support irregularities that automated systems could not resolve. Every time, the same pattern followed. The ships docked at human repair bays. And they left functioning. Trade networks began quietly sharing these reports. Captains spoke to each other during long journeys between systems, comparing experiences and rumors gathered from distant stations. Human repair crews, it seemed, had developed a peculiar reputation. Not for building the most advanced ships. Not for possessing the most powerful technology. But for fixing problems that no automated system could explain. Alien captains found the idea unsettling. For thousands of years, their civilizations had pursued technological perfection. Machines that monitored every variable. Algorithms that predicted every possible failure. Systems designed so precisely that maintenance had become almost unnecessary. Yet somehow, when something truly unexpected occurred, something no algorithm predicted and no automated repair routine could categorize, the solution was sometimes found in the most unlikely place. Inside a human repair bay. At first, most captains dismissed the rumors. Advanced civilizations did not rely on primitive mechanical techniques. Their technology was superior by every measurable standard. But space is vast, and eventually even the most confident captain faces a problem that refuses to follow established rules. And when that moment came, some captains began remembering the stories. Stories about a species that still repaired machines by hand. Stories about engineers who treated malfunctioning systems not as errors in code, but as puzzles waiting to be solved. Stories about noisy hangars filled with tools, sparks, and human mechanics who approached alien technology with curiosity instead of hesitation. Slowly, quietly, a pattern emerged along the edges of human space. Ships with unusual problems began appearing. At first only a few. Then more. They arrived damaged, malfunctioning, confused by failures their own creators could not explain. Their captains rarely announced why they had come. Officially, they claimed to be passing through. Unofficially, they requested access to the human repair bays. Human mechanics usually asked only one question. What seems to be the problem? Often, the captains could not answer. Their systems insisted everything was functioning normally, yet the ships clearly were not. Human technicians would nod, gather their tools, and begin looking anyway. Over time, alien observers started noticing something unusual about the way humans approached broken machines. They did not trust perfection. Where most advanced civilizations believed technology should never fail, humans assumed failure was inevitable. Their machines were not built around flawless performance. They were built around the expectation that something, somewhere, would eventually break. Because of that, humans had never stopped practicing the art of fixing things the hard way. They opened panels. They traced power lines manually. They listened to engines. They followed problems step by step instead of relying entirely on automated diagnostics. To older civilizations, this approach looked inefficient. But in rare situations, when something happened outside the predictions of perfect systems, those old habits began to reveal an unexpected advantage. And that advantage was the beginning of a quiet shift across the galaxy. A shift that would soon teach alien captains a surprising lesson. Sometimes the most advanced solution in the universe was a species that never stopped learning how to repair the impossible. The incident that changed everything began with a ship that should never have needed help. The cruiser belonged to one of the oldest technological civilizations in the known galaxy, a species whose engineering standards were considered nearly flawless. Their vessels were masterpieces of precision. Redundant systems monitored every component. Autonomous repair drones lived inside the walls, constantly scanning for irregularities and correcting them before they could spread. Their ships did not break. Yet one of them arrived drifting through human-controlled space, silent and powerless. Long-range sensors from a nearby human station detected the vessel first. At a distance it looked intact, no hull breaches, no debris field, no signs of battle. But the cruiser moved without propulsion, slowly rotating as if its guidance systems had gone dark. When communication was finally established, the alien captain sounded frustrated rather than panicked. Every automated repair protocol had been attempted. Every diagnostic system reported conflicting data. Nothing worked. Inside the ship, entire networks of repair drones had attempted to isolate the failure. The cruiser's artificial intelligence had run billions of system checks. Engineering algorithms searched for damage patterns across thousands of components. Each process reached the same conclusion: no identifiable cause. Yet the ship remained completely disabled. The captain had two choices: drift for weeks while waiting for a specialized fleet repair vessel from his home system, or dock at the nearest station available. The nearest station happened to be human. The decision clearly irritated him. To a captain accustomed to automated perfection, docking at a mechanical repair facility staffed by manual technicians felt like a last resort. But drifting helplessly through open space was worse. The cruiser entered the human station's outer hangar slowly, guided by emergency thrusters barely strong enough to stabilize its approach. Human engineers watched the massive alien ship settle into place. The scale of the vessel alone was intimidating. Its systems represented centuries of technological advancement beyond anything humans had created themselves. Yet, when the captain explained the problem, the mechanics reacted with something unexpected: curiosity. They began asking simple questions. What stopped working first? Did anything change before the shutdown? Any unusual sounds, vibrations, or temperature shifts? The captain found the questions strange. His own systems already monitored every variable those questions referred to. The answers were already stored in diagnostic logs. Still, he provided the data. Human technicians studied the information briefly, then began requesting access to sections of the ship the alien engineers had barely examined. Instead of analyzing everything through centralized diagnostic systems, the humans spread throughout the vessel. They opened maintenance panels. They followed power conduits through the interior. They inspected mechanical assemblies that automated drones normally handled without supervision. The alien engineering team watched with growing confusion. None of the humans relied heavily on the ship's internal AI. They were looking directly at the hardware. At first it seemed pointless. The cruiser's systems were far too complex for unfamiliar technicians to understand quickly. Even the alien engineers required specialized training to maintain them. Yet the humans did not attempt to master the entire design. They searched for smaller clues. One mechanic noticed a slight irregularity in the energy flow between two power distribution nodes. Another found that one of the ship's stabilizing circuits was cycling through power states too quickly. A third technician discovered a microscopic fracture inside a relay housing, too small to trigger automated replacement protocols but large enough to disrupt signal timing. Individually, none of these issues seemed catastrophic. Together, they created a cascade of contradictions inside the ship's control systems. The cruiser's automated diagnostics could not identify the root cause because each subsystem appeared technically functional. No single component had fully failed. But the humans approached the problem differently. Instead of asking which system was broken, they asked how the systems were interacting. Within a few hours, they isolated the chain of interference. One damaged relay caused a minor timing delay. That delay triggered compensations in adjacent circuits. Those compensations produced conflicting sensor readings across several systems, which in turn confused the automated repair algorithms. The ship's AI had essentially trapped itself in a loop of perfectly logical but incorrect conclusions. The solution did not require replacing major components. It required interrupting the loop. Human technicians bypassed the fractured relay with a temporary circuit bridge, recalibrated the stabilizing circuits manually, and reset several synchronization timers the automated systems had locked into place. The changes were simple, unorthodox, and completely outside standard repair protocols. Alien engineers initially objected. The modifications violated multiple engineering guidelines. Some of the temporary connections would never have been approved during original construction. But the human mechanics insisted on testing the changes. Power returned to the cruiser's systems. Lights across the ship flickered back to life. Control interfaces rebooted. Propulsion engines began warming for activation. For the first time since the malfunction began, the cruiser's AI reported consistent diagnostic readings. The alien captain stood in stunned silence. His civilization had designed the ship. Its automated systems had analyzed the failure for days. Entire swarms of repair drones had searched for the cause. Yet the solution came from a group of humans with handheld tools and a willingness to try something unconventional. The cruiser departed the station fully operational. Before leaving, the captain transmitted a detailed report to his home system. At the end of the report, he included one final observation. Human repair methods were inefficient, unpredictable, and highly irregular. But under certain conditions, they worked. The report from the cruiser spread faster than anyone expected. At first it circulated only among engineering circles within the captain's civilization. Their scientists and technicians reviewed every detail of the repair. They examined the diagnostic logs, the circuit rerouting, the manual recalibrations, and the temporary bridge that bypassed the fractured relay. The conclusion confused them. Nothing the humans had done was technologically advanced. The tools they used were simple. The adjustments were direct and mechanical. In some cases, the repairs even violated the strict engineering protocols that governed alien ship design. Yet the outcome could not be denied. A ship that automated systems declared unsolvable had returned to full operation within hours. Other civilizations soon obtained the report through shared trade networks. Independent engineers studied the repair sequence, searching for a deeper technological trick hidden within the human methods. There was none. The humans had not relied on superior technology. They relied on something else: perspective. Most advanced species designed their technology around the assumption that machines should operate perfectly. Their systems constantly monitored themselves, correcting irregularities before those irregularities could evolve into larger failures. Over centuries, this pursuit of perfection produced machines that rarely broke, but it also produced engineers who rarely experienced true mechanical failure. When something unexpected happened, their automated systems searched through predefined categories of malfunction. If the problem did not fit one of those categories, the system struggled to respond. Human engineers approached machines differently. Human technology had never been perfect. Throughout their history, machines failed constantly. Engines overheated. Circuits burned out. Materials fractured under stress. Entire systems collapsed because a single component behaved unpredictably. Instead of eliminating failure completely, humans learned to live with it. They designed machines that could be opened, examined, and repaired manually. They trained engineers to understand not just how systems should work, but how they might behave when something went wrong. Failure was not an anomaly in human engineering. It was an expectation. Because of that, human mechanics developed habits that seemed strange to alien engineers. They listened to machines. They watched how systems interacted rather than studying them individually. They trusted physical observation as much as diagnostic data. Most importantly, they were comfortable trying solutions that had never been programmed into an automated repair system. One human mechanic later explained the philosophy in a short message attached to the cruiser's repair log. Machines break. That's normal. The important part isn't preventing every failure. The important part is figuring out how to fix whatever happens. To alien engineers, the statement sounded almost careless. Their civilizations had spent thousands of years building technology designed to eliminate uncertainty. Human mechanics appeared to accept uncertainty as a natural part of engineering. But the more alien scientists studied the repair logs, the more they noticed something interesting. The humans had not simply guessed their way to a solution. They followed the chain of cause and effect through the ship's systems step by step. They ignored the automated assumption that every component was functioning correctly and instead tested how those components interacted in real conditions. In other words, they investigated the problem as if the entire ship was a puzzle. Not a system. A puzzle. Once alien engineers recognized this difference, they began reviewing other reports from ships that had visited human repair bays. The pattern became clearer. Human mechanics rarely solved problems using identical methods twice. Even when ships experienced similar malfunctions, the solutions often varied depending on the specific circumstances. Automated systems preferred predictable solutions. Humans preferred adaptable ones. Where most civilizations relied on machines to follow strict logical procedures, human engineers allowed themselves to improvise when logic alone failed. This realization unsettled many alien researchers. Improvisation had largely disappeared from advanced engineering. Perfect systems left little room for unpredictable adjustments. Yet the cruiser incident proved that unpredictability sometimes created opportunities that rigid systems missed. Gradually, a quiet understanding began spreading through engineering communities across the galaxy. Human repair crews possessed a rare skill that automation could not easily replicate. They could adapt in real time. When confronted with a malfunction that did not match any known pattern, humans did not wait for a new algorithm to be written. They experimented. They observed. They adjusted. And eventually, they solved the problem. To civilizations accustomed to flawless machines, this method seemed messy and inefficient. But space was full of unknown variables. Radiation storms. Gravitational distortions. Microscopic structural stresses that accumulated across years of travel. Interactions between systems that no designer had predicted. In those rare moments when perfection failed, something surprising became clear. The species most prepared to deal with broken machines was the species that had spent its entire technological history fixing them. The cruiser's repair was only the beginning. Within weeks, the captain's report circulated through trade guilds, navigation networks, and engineering databases across multiple star systems. At first, it remained a technical curiosity, an unusual case where human mechanics solved a problem automated systems could not. Then more ships began arriving. A cargo carrier entered human space with propulsion engines that repeatedly shut down during long-range travel. Diagnostics insisted the engines were functioning within acceptable parameters, yet every attempt to reach faster-than-light speeds triggered a system halt. Human technicians spent several hours studying the propulsion core. Instead of replacing expensive components, they discovered a minor synchronization error between two control circuits, something the automated monitoring software considered too small to classify as a malfunction. After a brief recalibration and a manual adjustment to the timing regulators, the engines performed flawlessly. The cargo captain left quietly, but his message spread through merchant channels. Not long after, an exploration vessel appeared with environmental systems that randomly fluctuated despite perfect diagnostic readings. Its creators had spent days analyzing sensor data without identifying the cause. Human mechanics traced the problem to a subtle interference pattern between two atmospheric processors, an interaction the ship's designers had never anticipated because the processors were never meant to operate under certain overlapping conditions. The fix required no new technology. Only a small modification to how the processors communicated. Once again, the ship departed fully operational. Patterns like this began repeating across human repair stations. Ships arrived with problems that did not fit existing maintenance categories. Automated repair systems stalled because they could not classify the malfunction. Human mechanics approached each situation differently. They rarely trusted the first diagnostic result. Instead, they examined how systems interacted under real operating conditions. They treated every malfunction as a unique puzzle rather than a predictable failure pattern. Alien captains began noticing something even more unusual. Sometimes ships left human repair bays performing better than before. A freighter returned to the trade lanes with more stable engine output after a human technician adjusted a power flow configuration the original designers had never questioned. A research vessel reported improved navigation stability after humans corrected a small alignment inconsistency between sensor arrays. These changes were not upgrades in the traditional sense. They were refinements, tiny adjustments discovered through hands-on observation rather than automated analysis. For civilizations accustomed to perfect systems, the idea was unsettling. Their engineers had believed their designs were already optimized. Yet human mechanics occasionally uncovered small improvements simply by examining machines without the assumptions built into their diagnostic programs. Soon captains traveling through distant sectors began sharing a quiet piece of advice. If your ship experiences a malfunction that your own systems cannot explain, do not wait for specialized repair fleets. Find the nearest human station. The advice spread gradually, not through official channels but through personal experience. Merchant captains spoke to each other at trade ports. Patrol officers shared stories during long escort missions. Explorers passing through unknown regions remembered the reports when their own systems behaved unpredictably. Human repair bays slowly transformed from overlooked outposts into essential emergency ports along major routes. Ironically, the humans themselves never claimed superiority. To them, the work felt normal. Machines broke. Engineers fixed them. Every repair was simply another problem waiting to be solved. But to the rest of the galaxy, the pattern revealed something remarkable. Advanced civilizations had spent centuries designing machines that avoided failure. Humans had spent centuries learning how to deal with it. That difference created a skill no automated system could easily replicate. Human mechanics did not expect machines to behave perfectly. They expected surprises. And when those surprises appeared, they were ready. Across countless star systems, captains eventually reached the same conclusion. When technology works exactly as designed, any advanced repair system can maintain it. But when something truly unexpected happens, when flawless machines begin behaving in ways their creators never predicted, the most valuable engineers in the galaxy are not the ones with the most perfect tools. They are the ones who never stopped learning how to fix the impossible. And more often than not, those engineers are human.